All right, let's jump right into it right here. This calls me mathcitement, which is a combination of math and excitement. We're going to be going over the worksheet from a table. We're going to be determining if the table tells us that we are looking at a linear, a quadratic, or an exponential function. I'm Mr. Trutna. This is Math 2. We are at Clovis High School, and what we're going to do is we are going to skip all the way to the third page. And we're going to skip all the way to the last two pages because that's really where all the work is going to be done, okay? So you're skipping to the very last piece of paper on the handout where the directions say, and this would be the last page of the handout, the last piece of paper, where it says determine if each table is linear, quadratic, or exponential. Fill out the first difference, second difference if necessary, and common ratio if necessary. Okay, so remember how we talked about in class, it is very easy to tell if an equation is linear if you are given a picture. As a picture, a linear equation is going to make a line. As a picture, a quadratic equation is going to make a parabola. And the parabola could be facing up like this one, or it could be facing down. And as a picture, an exponential equation is going to be a smooth curve. And this smooth curve is going from left to right. You could have it going from right to left. So it could be going like that. You kind of trace it like that, okay? But the problem is that we're dealing with is we're not dealing with pictures. We've progressed beyond pictures or graphs. We're looking at tables, and we're trying to tell, is this table going to be linear, make a line, quadratic, make a parabola, or exponential, make a smooth curve? And we're going to try to do it without making the picture, without graphing it at all. Okay, so how do we do this? Well, what we do is we look at the y values. So you focus in on the y values. And the first thing that you do is you focus in on the very first two y values. In this case, 14 and 10. And you ask yourself, you say, all right, so I'm at 14 and I'm moving to 10, so I'm decreasing. So I know that my y values from there to there is decreasing. And so now in math, how do you make a number, one number decrease to another number? Well, there's only two ways to do it. You could either divide or you could subtract, okay? When we're talking about the four major operations. So we know that this y, it's either a division or it's a subtraction pattern. We're looking for a pattern that happens, okay? Well, let's start with division. Can you think of a number that you would divide into 14 to turn it into 10? Does any number come off the top of your head? I can't think of a number that 14 divided by what is equal to 10. So I know that probably this is not going to be a pattern involving division. Okay, how about subtraction? Can you think of a number that you would subtract from 14 to turn it into 10? Yeah, you are subtracting 4. Okay, so along this first difference column, what we're going to do is we are going to look at from one y to the y below it. So the next one we're going to look at 10, and we're going to see, is there a pattern developing to get from one y to the y value below it? Okay, so how do I get from 10 to 6? Well, that would also be subtracting 4. So right now I'm thinking in my head, well, the pattern must be subtracting 4. Let's see if it follows the pattern. How about 6? 6 subtract 4, is that 2? Yes, it is. So I'm subtracting 4. Let's keep going. 2 subtract 2. 2 subtract 4. Is that give me negative 2? Yes, it does. Okay, so my pattern is definitely developing, and then negative 2 subtract 4 is negative 6. So you can see that my pattern is come from my first difference column right here. Okay, now, so what is it? So remember, if the pattern involves addition or subtraction, the first pattern involves addition or subtraction, then we know that this is a linear function. So this first table right here, it is a linear function, okay? And we're going to go through it and we're going to look at each table and see what happens here. All right, so now we go to the second table. So I've got my table right here. Remember, I focus in on the first y value and I focus in on the second y value. And I ask myself, is it increasing or is it decreasing? Well, I'm going from 1/2 to 1, so that's increasing. So using one of the math operations, addition, subtraction, multiplication, or division, which ways can I increase a number? I could use addition or I could use multiplication. So I'm looking, I'm saying, is the pattern multiplication or is the pattern addition? Okay, I'm looking for a pattern. Well, let's look at multiplication. What would I multiply 1/2 by to turn it in to make it equal to 1? Well, I would multiply by 2. All right, so down over here in the common ratio, I'm going to put a times 2. All right, common ratio means what are you multiplying or dividing by? Okay, then let's see if this times 2 pattern stays the same throughout all the y's. So if I took 1 and if I multiplied it by 2, does that equal 2? Yes, it does. So I have another times 2. How about 2? If I took 2 and if I multiplied it by 2, does it equal 4? Yes, it does. So you can see I have a pattern developing here. I'm multiplying by 2 each time. 4, if I take 4 and I multiply it by 2, it equals 8. If I take 8 and I multiply it by 2, it equals 16. So you can see that my pattern that is developing is that I'm multiplying by 2. Okay? And when we are multiplying, if we're developing a pattern by multiplication or division, we say there is a common ratio. So that means there is a common ratio. Well, if there is a common ratio, then what type of function is it? It is exponential. So this table would be an example of an exponential function. Okay? So that would be that one. All right, the third one right here. So here we go. So I've got my table. I look at my first y value, 21. I look at my second y value, 12. So I'm decreasing. Well, how do you decrease? Well, you could either divide or you could subtract. Which one is it most likely? I would say it's most likely going to be subtraction. And the reason is because I can't think of a number that I would divide into 21 to make it equal to 12. So I'm going to throw that out. All right, so how about subtracting? What am I subtracting by? 21 subtract 9 is equal to 12. Okay? And let's just keep going. Let's just go with the subtraction and see what happens. So what would I subtract from 12 to turn it into 5? Well, that would be subtract 7. So 12 subtract 7 is 5. Okay? How about 5 to 0? Well, I would subtract 5. 5 minus 5 is equal to 0. How about 0 to negative 3? Well, I would subtract 3. 0 subtract 3 gives me negative 3. And how about to get from negative 3 to negative 4, I would subtract 1. So I look at my differences through subtraction, and you can see those numbers are not all the same. So I know it's not linear. It's only going to be linear if the first pattern, all the numbers are the same, okay, by addition or subtraction. All right, I know it's not division because I can't divide anything by 21 easily to get 12. So when that happens, what I have to do is I now have to change my focus into the second list of numbers here. All right, and then I have to see, is there a second pattern that's being developed? All right, so in other words, to get from negative 9 to negative 7, is that increasing or decreasing? Well, that's increasing. How much is it increasing by? It's increasing by 2. Okay, so now I'm going to see, is the pattern always increasing by 2? All right, negative 7. If I increase that by 2, if I add 2, do I get negative 5? Yes, negative 7 plus 2 is negative 5. All right, let's keep going. How about negative 5? If I take negative 5, I add 2 to it, does it equal negative 3? Absolutely. How about if I take negative 3? If I add 2 to negative 3, do I get negative 1? Yes. So you can see that there is a pattern, but the pattern is in the second pattern. The first pattern didn't really give me a pattern, but the second pattern gave me a pattern of addition. So if the second pattern, which we call the second difference, shows you a pattern, and if it involves addition or subtraction, this is telling you that you are looking at a quadratic function. So this third one right here is going to be a quadratic function. All right? The fourth one, my first y value is negative 16, my second y value is negative 13. All right, so I am increasing. So how do we increase? Well, there's two ways mathematically to increase. I could either multiply or I can add. Can you think of a number easily that you would multiply negative 16 by to turn it into negative 13? I can't, so I'm going to assume that it's addition. So what am I adding by? What would I add negative 16 by to get negative 13? I'm increasing by 3. Okay, how about negative 13 to negative 10? I'm increasing by 3 again. How about negative 10 to negative 7? Once again, I'm increasing by 3. How about negative 7 to negative 4? I'm increasing by 3. Negative 4 to negative 1, I'm increasing by 3. So, if the first difference gives you a pattern and the pattern involves addition or subtraction, we know that this is going to be a linear function. So this one would be an example of a linear function. All right, moving on to the next one. All right, here's my table. I look at my top y value, which is negative 14, and you can see that I'm increasing to negative 9. So how much am I increasing by? Okay, once again, to increase, you either multiply or you add. Well, multiplication, it's not just straightforward, so we're going to rule that one out. We're going to look at addition first. All right, so negative 14, what would you add to negative 14 to make it negative 9? You would add 5. Let's keep going. Negative 9, what would you add to negative 9 to make negative 4? We would add 5. Okay, how about negative 4? What would we add to negative 4 to turn it in equal to positive 1? We would add 5. How about 1? What would I add to 1 to make it equal to 6? I would add 5. 1 plus 5 is 6. 6 plus 5 is 11. So my pattern is found in my first pattern here, and it's all addition. So once again, if the first pattern is addition or subtraction, this tells us that we are looking at a linear function. Okay, so that one's going to be a linear function. All right, the next one right here, last one on this page. I start to determine what it is. I start at my top y number, negative 18, and you can see that it increased to negative 6. Okay, so how do we get something to increase? Well, we could either multiply or we could add. All right, so what am I doing here to get from negative 18 to negative 6? All right, well, one way to get it is, let's look at multiplication. What would I multiply negative 18 by to turn it into negative 6? Well, actually, I wouldn't multiply. I would divide by 3. Okay, so I would say that my common ratio, I'm going to look at dividing by 3. I see that negative 18 divided by 3 is negative 6. Let's see if that follows the pattern. So if I took negative 6 and I divided it by 3, does it equal to negative 2? Yes, it is. So I have another divided by 3. Okay, how about this one? If I took negative 2 and I divided it by 3, does it equal to 0? All right, well, no, it doesn't. So that means that division or multiplication, that's not my pattern. So I could rule this one out. Okay, well, what's another way to increase? Well, another way to increase is by addition. So what would you add to negative 18 to turn it into negative 6? I would add 12. What would you add to negative 6 to turn it into negative 2? You would add 4. All right, what would you add to negative 2 to turn it into 0? You would add 2. What would you add to 0 to turn it into 2? You would add 2 again. What would you add to 2 to turn it into 4? 6, I mean, you would add 4. So you can see right here that there's no pattern in the first difference, okay? So if there's no pattern in the first difference, what do? Well, we look at the second difference and we see what's happening. See if there's a pattern in the second difference. So what would you do to positive 12 to decrease it to 4? You would subtract 8. What would you do to 4 to decrease it to 2? You would subtract 2. What would you do to 2 to keep it as 2? Well, that would be, you would add 0. How about to get from 2 to 4, you would add 2. So is there a pattern in the second difference? There is not. Okay, so there's no common ratio. There's no pattern at all, so what does this tell us right here? This one is going to be none of the above. So this tells us that this is it could be some type of function, but it's definitely not linear or quadratic or exponential. All right, we got a couple more to go here. So here we go, the first one right here. So I look at my top y value, 4, I can see that it increases to 8. Okay, well, what's a way to increase? Well, right away, I think, all right, this could be multiplication. I could multiply by 2, all right, because 4 times 2 is 8. Let's see if that pattern holds. If I take 8 and I multiply it by 2, does it equal 16? Yes, it does. So I have another multiplying by 2. How about 16? If I take 16 and I multiply it by 2, does that make 32? Yes, it does. So you can see that I have a common ratio of 2. So each time you can see I'm always multiplying by 2 from one y value to get the y value underneath it. Okay? So there is a common ratio. It is multiplying by 2. If you have a common ratio, that means that this is an exponential function. So this one would be an example of an exponential function here. Okay, all right, moving on to this one over here. This one's a little bit tricky because if you notice, my first y value is 1/27, but then I increase it to 1/9. All right, so how do I increase? I multiply, or I guess I could divide. All right, so what do I do here? So what am I doing? Well, what would I do to 1/27 to turn it into 1/9? Okay, so in other words, what would I do to make this, what would I do to the 27 to turn it into 9? Well, that's a division problem. I know that 27 divided by 3 is 1/9, so I am dividing by 3. Okay, so I'm multiplying by 3. Why does it have to be multiplication? Well, I'm getting larger. Okay, how about 1/9? If I took 1/9 and I multiplied it by 3, what does it equal? Well, that would be 3 over 9, which is 1/3. So you can see I'm developing a common ratio of multiplying by 3. All right, so 1/3, if I multiplied 1/3 by 3, does it equal 1? Yes, it does. So I'm multiplying by 3. If I took 1 and multiplied it by 3, 1 times 3 is 3. So I have another ratio of multiplying by 3. And then if I took 3 and I multiplied it by 3, 3 times 3 is equal to 9. So since I have a common ratio of multiplication, what type of function is that? Well, once again, that's going to be an exponential function. So this table right here is going to be an exponential function. Moving on to the next table here. Let's look at the pattern. Let's try to find a pattern. So I look at my first y value, which is 30, and you can see that it's decreasing down to 20. Well, what's a way to decrease? Well, we could either be dividing or we could be subtracting, okay? Division is not clear. There's nothing that I can think of just right away that I'm dividing the 30 to turn it into 20. So let's think subtraction. So it's decreasing by how much? Well, we're decreasing by 10. Then I go from 20 to 12. Well, that's decreasing by 8. Then I go from 12 to 6. Well, that's decreasing by 6. Then I go from 6 to 2. Well, that's decreasing by 4. And then I go from 2 to 0, and that's decreasing by 2. So, looking at the first pattern, there is no pattern. Okay, so what happens if there's no pattern in the first pattern? Well, then I look at the second pattern. And then I say to myself, all right, so I'm going from -10 to -8, so that's increasing. And how much am I increasing by to get from -10 to -8? I'm increasing by 2. How about from -8 to +6? I'm increasing by 2. How about -6 to -4? Once again, I'm increasing by 2. How about -4 to -2? I'm increasing by 2. So if there is a pattern, but it's the second pattern, that tells me that we're looking at a quadratic function. So this table would be an example of a quadratic function. Moving over to this table right here, you can see that my first y value is 11, and then I'm decreasing to 9. So what's the simplest way? Just think simple. To decrease from 11 to 9, well, we're decreasing by 2. All right, how about then I decrease from 9 to 7? I'm decreasing by 2. Then I'm decreasing from 7 to 5, so I'm decreasing by 2. Then I'm decreasing from 5 to 3, so I'm decreasing by 2. And from 3 to 1, I'm decreasing by 2. So as we can see from this table, the pattern is being developed in the very first pattern. It's involving, if the very first pattern is being developed and it's addition or subtraction, this tells me that this is a linear function. Okay? So that would be a linear function because the first pattern was developed and it involved addition or subtraction, in this case subtraction. Okay, all right, the next one, I start at 1/9 and then my next y value is 1/3. So I increased in value. All right, so how do you increase from 1/9 to 1/3? Just think of the simplest way possible. Well, one way that we could do it is we could multiply by 3. So I'm going to go over here to my common ratio. And then I'm going to see if that ratio holds. So 1/3 increased to 1. So is that multiplying by 3? It is. 1/3 times 3 is 1. Okay, then if I'm at 1 and I increase it to 3, I could multiply by 3. So you can see my pattern is developing right away, and my pattern is multiplication by 3 every time. 3 times 3 is 9. 9 times 3 is 27. So my pattern is being developed by multiplication. And it was my first pattern that I developed. So when that happens, when your pattern is being developed by multiplication or division, that tells you that this table is an example of an exponential function. Okay, the next table, you can see this one. I start at 0 and I increase to 5. So how do you increase from 0 to 5? Think about the easiest way to do it. That would be adding 5. So my first numbers here, I'm adding 5. But now the second one, you could see I'm increasing, but I'm only increasing by 3. So right away, I know it's not linear because my first pattern is not a pattern. Okay? But now you could see I went from 8 to 9. So I increased by 1. But then I went from 9 to 8. So I decreased by 1. And then I went from 8 down to 5. So I decreased by 3. So there is no first difference. So I know it's not linear. And I know it's not multiplication. There's nothing you could multiply 0 by to turn it into 5. That's impossible. Okay? So then what I have to do is I have to look at my second difference. And I have to go, okay, so here my first, I have to see if there's a second pattern. So I look at this 5 and I go, all right, I went from 5 to 3. So I decreased by 2. Then you go from +3 to +1. So what are you doing? You're decreasing by 2. Then you go from positive 1 to negative 1. Well, that's also a decrease of 2. And then you go from negative 1 down to negative 3. So that means there's a decrease of 2. So there is a pattern, but it's developed in the second pattern. So when you have a table that develops a second pattern like this one, this tells you that you are looking at a quadratic function from that table. Okay. All right, the last one. I have 3, and then it decreases into 0. Remember, I'm always looking at the y values here. So how do you decrease from 3 to 0? Think simple. All right, well, simple would be I would subtract 3. So to get from 3 down, I'm decreasing to 0, so I just decreased by 3. Okay, then I went from 0 to negative 1, so I decreased by 1. Then I went from negative 1 and I increased to 0, so I increased by 1. Then I went from 0 and I increased to positive 3, so I increased by 3. And then I went from 3 and I increased to 8, so I increased by 5. So there is no pattern right away. Okay, so since there's no first difference pattern, we know it's not linear. All right, and I know it's not going to be exponential because there's, what would I multiply 3 by or divide 3 by? I can't divide 3 by anything to turn into 0. The only thing I could multiply it by would be 0, but that would make all of these 0. So I know it's not this. So I got to see if there's a second pattern. So let's see if there's a second pattern. Okay, so I went from negative 3 and then I increased to negative 1. Well, that's an increase of 2. Then I went from negative 1 and I increased to positive 1. That is also an increase of 2. Then we went from positive 1 to positive 3, so once again we increased by 2. Then we went from positive 3 to positive 5, so you can see we increased by 2. So there is a pattern, but it's the second pattern. So what type of function is it? When you find a second pattern and it involves addition or subtraction, this is telling me I have a quadratic function. Okay, so come to class and ask questions if you're not sure and you need to clarify any of these answers.